So now I have the fixture locked and loaded into our DMG Mori DMU50. I've gone through and made sure that the position and orientation is correct per my setup sheet. The reason why is we specifically had to change the position of the fixture so that way we can get the most travel out of our setup. The back and the front of this table are actually cut in a little bit, which allows us to go deeper with the spindle. So now that I have it properly positioned and orientated, I'm gonna go through and check my setup sheet. Once I've checked everything and made sure that it's completely perfect, we're ready to go ahead and machine this fixture complete. Then we're gonna move on to the next operation, which is actually machining the Titan 513M in the DMU. All right, so our first tool is a Kennametal Stelram 3-inch face mill. We are actually going to bring the tool down and cut our top surface, but we're gonna spin the table and just move one of our axes. This is gonna allow the face mill to cut the whole entire profile without over traveling, since our material is actually larger than the envelope of what we can machine.
The tool that I used was T1, which is a 3-inch Stelram Kennametal face mill. My SFM is 6,509. My spindle speed is 8,373. My feed rate is 78 inches per minute. My feed per tooth is 1 thou 6/10, and I have a plunge feed rate of 100 inches per minute. Next, I have the cut parameters tab. In here, I made sure and turned off compensation type from where I set it to off, so the tool would stay in center of the line that I drew. This is important so that way I can properly get to the center of my part.
Next is our 1/2-inch end mill. This is going to make the counterbores in which we will install the Mighty Bite ID expansion clamps into our fixture.
The tool that I'm using is T2, my 1/2-inch 3-flute Kennametal end mill. My SFM is 1,443. My spindle speed is 11,128. My feed rate is 105. My feed per tooth is 3 thou 2/10. My plunge rate is 100 inches per minute. In my cut parameters tab, I have a step over of 15% or 75 thousandths. I have a minimum toolpath radius of 25 thou, so that way my end mill doesn't get too tight and stall in its toolpath. For my linking parameters, I have the bottom of the pocket selected. My feed plane is 100 thou, and I have a retract plane of 1/4 inch. I'm using a 2D contour to come in and finish these pockets. I'm going with a SFM of 654. My spindle speed is 5,000 RPM. My feed rate is 25 inches per minute, and I have a feed per tooth of 1 thou 7/10. I have a plunge rate of 100 inches per minute since all the material has been cut out. In my cut parameters tab, I'm going to make sure that I have compensation type set to where, so that way I can adjust the size of my pocket. Everything else I'm just going to leave at 0. Lead in, lead out, I'm going to do 10% for length and for arc, both entry and exit. The next tab is going to be the linking parameters tab. My depth is the bottom of the pocket. The top of stock is 0. Feed plane is 100 thou. And my retract plane is going to be 1/4 inch.
All right, the next tool is actually going to be a 37/64 go drill. We're actually going to use this drill to go ahead and make the miner for our 5/8 threads.
I'm going 719 SFM with a RPM of 4,757. My feed rate is 76 inches per minute with a feed per tooth of 8 thou. For our cut parameters, using a G81 drill cycle, and in the linking parameters, I have the bottom of the hole selected. My top of stock is 0. My retract is 100 thou, and I have a clearance plane of 1/4 inch.
Next is tool number 4. This is our 5/8 cut tab that we're going to use to make our thread.
My SFM is 53, my spindle speed is 329, my feed rate is 30 inches per minute, and my feed per tooth is 90 thou. For my cut parameters, we're going to be using a 84 cycle, which is like a G54. Our linking parameters, we are going to use the bottom of our thread. My top of stock is 0, and my retract plane is 100 thousandths. My clearance plane is 1/4 inch, and all of these combined will give us the appropriate thread. The next tool path, we are actually going to come in with a 1/2 inch end mill. We're actually going to cut out our counterbore for bushing that we will be adding later. My SFM is 742, my spindle speed is 5,676. I'm going 15 inches a minute because I do want a nice fit for my bushing. For the lead in, lead out, we have a perpendicular entrance of 10%, which will go in and cut our bore. For my linking parameters, I have the bottom of the counterbore selected. My top of stock is going to be the top of our part. My feed plane is 100 thou. For my depth, I have the bottom of the counterbore selected. Top of stock, feed, and retract are all normal. My clearance plane is going to be 1/4 inch. And all of this combined, we'll go ahead and cut out these counterbores.
Next is tool 10, which is our 5/8 dual lock chamfer mill, which is what we're going to use to go ahead and chamfer the threads that we just made.
My SFM is 1,390. My spindle speed is 8,500. My feed rate is 50 inches per minute. My feed per tooth is 1 thou, and my plunge rate is 100 inches per minute. In my cut parameters, I have my compensation type set to wear, but my contour type is set to 2D chamfer. This will automatically give us a chamfer toolpath with a chamfer width of 10 thousandths, and the depth of the tool that will go below my selected contour is going to be 80 thousandths.
Next is T5, which is our 1/8 go drill, which is what we're going to use to make our 632 threads.
I have a SFM of 360. My spindle speed is 11,000 RPM. My feed rate is 66 inches per minute with a feed per tooth of 3 thou. In my cut parameters, I'm using a cycle 81. This means that my drill will feed in and wrap it out. My top of stock is negative 100 thousandths, and same thing with my retract. You must have clearance plane selected of 1/4 inch, so that way the tool can actually lift up and around each pocket.
All right, next is tool number 6, which is going to be our 632 roll tap.
I'm going with an SFM of 17. My spindle speed is 480. My feed rate is 15, and my feed per tooth is 31 thousandths. I'm using a cycle 84 to go ahead and tap this particular thread. So in my linking parameters, I have a clearance plane of 1/4 inch. My retract and top of stock height are both negative 100 thousandths. This will save me some time and let the tool rapid down into the pocket before it starts cutting our thread. To hit my thread depth, I have a negative value of 0.65. This will give me the correct depth for my 632 threads.
All right, next is T7, which is our Q drill, which is what we're going to use to make our threads for our 3/8/16 king certs that we'll be using for our Mighty Bite ID expansion clamps.
I'm going 540 SFM. My spindle speed is 6,251. My feed rate is 75 inches per minute, and my feed per tooth is 6 thousandths. In my cut parameters tab, we're going to be using a cycle 81 to go ahead and drill this out. For my linking parameters, my clearance plane is going to be 1/4 inch. Both my retract and my top of stock plane have a negative value of 100 thousandths, just as before. For my depth, I have the bottom of the hole selected. All of this will go ahead and give us this toolpath where we will draw out the miner for our thread insert for our 3/8 16 threads.
All right, next we have T8, which is our 3/8 16 cut tab, and which we're going to use to go ahead and make our threads.
I'm going with a SFM of 19.6. My spindle speed is 200 RPM. My feed rate is 12.5 inches per minute, and my feed per tooth is 0.0625. For my cut parameters, I'm going to be using cycle 84 to tap this thread. For my linking parameters, I have a clearance plane of 250. My retract and top of stock, just like before, are going to have a negative value of 100 thousandths. For my depth, I have a calculated number of 0.825. This will give me the appropriate thread for my thread insert.
Next is T9, which is our 1/4 inch chamfer mill, and it's what we're going to use to go ahead and make these spots for our 632 threads.
My SFM is 658. For my spindle speed, I'm going 10,000 RPM with a feed rate of 50 inches per minute. My feed per tooth is 2 thou 5/10. My plunge rate is going to be 100 inches per minute. I have my compensation type set to wear. My contour type is set to 2D chamfer. My chamfer width has a value of 10 thousandths, and my bottom offset, or how far the chamfer is going below my material, is going to be 80 thousandths. For my lead in and lead out, I have a length and arc of 10%. For my linking parameters, I have a depth of 0, since we already have the depth called out in my cut parameters tab. My top of stock is 0. My feed plane is going to be 100 thousandths, and my retract plane is set to 1/4 inch. For our next toolpath, we're actually going to chamfer our 632 threads. My SFM is set to 392. My spindle speed is set to 6,000 RPM. My feed rate is going to be 20 inches per minute, and my feed per tooth is 1 thou 7/10. In my cut parameters tab, we have our cycle set to 81, which will feed our tool in and wrap it out. The linking parameters, we have a calculated chamfer size and depth value of 0.378. My top of stock and retract height both have a negative value of 100 thousandths. My clearance plane is set to 1/4 inch, so that way my tool properly clears all of these pockets.
Next is T11. That is our 29/64 go drill, and is what we're going to use to make our 1/2 threads for our king inserts.
The SFM is 741 with a spindle speed of 6,251. My feed rate is going to be 45 inches per minute, and my feed per tooth is 3 thou 6/10. Next, for the cut parameters, we have a cycle of 81. My linking parameters, I have a clearance height of 1/4 inch. My retract height is going to be 100 thousandths. The top of stock is 0, and the bottom of our hole is going to be our drill depth.
Next is T12, which is our 1/2 cut tap. This tap is what we're going to use to make our 1/2 threads for our fixture.
My SFM is 28. My spindle speed is 221. My feed rate is 17 inches per minute, and my feed per tooth is 76 thou 9/10. In my cut parameters, we have a cycle of 84, which is our normal tapping cycle. For my linking parameters, we have a clearance plane of 1/4 inch with a retract plane of 100 thousandths. My top of stock is going to be 0, and the depth is the calculated value of the bottom of our thread. We're only going down 0.9, so that way we can fit our thread insert in there. This is the appropriate depth for us to use our kingserts.
Next is T2, which is our 1/2 inch end mill. This is what we're going to use to bore the top of our thread underneath our fixture 100 thousandths, so that way the thread insert starts below our iso grid, which will help us later on in our process.
For my cut parameters, we have a cycle 81 selected, which will allow us to feed in and wrap it out. For my linking parameters, we have a clearance plane of 1/4 inch. My retract height is set to 100 thousandths. The top of stock is 0, and the depth is -100 thou.
Okay, next is T10, which is our 5/8 dual lock chamfer mill, and it's what we're going to use to make a chamfer on our half 13 threads.
We're going with a SFM of 196. My spindle speed is set to 1,200 with a feed rate of 20 inches per minute, and my feed per tooth is 2 thou 8/10. I'm going so slow to ensure a nice, smooth chamfer that won't chatter in each of these pockets. In my cut parameters tab, we have a cycle 81 for our normal drilling. In my linking parameters tab, we have a clearance plane of a 1/4 inch. Both my retract and top of stock heights are both -100 thousandths. For my depth, I pre-calculated my chamfer size plus the distance needed to reach the bottom of the pocket. All of that will give me a nice perfect chamfer toolpath.
So we just got done machining our fixture. Now that it's completely machined and ready to go, we're now ready to install our Mighty Bite hardware.